I'm going to continue then with our session here of classes. We have now B class. Since it's here on this bit, it starts at 128.0.0.0 and it ends at 191. I'm sorry, no, 128 dot, yeah, 0.0.0, right? Then it was 192.0.0.0, yeah. I believe that's how it is. But we'll get into the details. But that's how I know how it starts. As for the actual subnetting or of the private versus public, we'll get into the details now. But this is a quick summary of how you could tell where each IP lands, how it starts. We agree that there is IP subnets, which obviously then impact the classes itself. So what's the default subnet for a class A?
The subnet will be 255 and the rest of the 3 octaves should be 0.
Okay. What's the default for B?
Similar to A, except that octave 1, 2 will be 255, the rest should be 0.
Okay, if someone else can help me now with C, if we see a pattern, if somebody can help us with C, what's the default there?
255, 255, 255, 0.
Okay, and that's basically the main subnets that are out there in their classes. These are the IPs, and then these are the default subnets, A, B, and C subnets. D we said was for multicasting, so that's not being used by anybody except for people who are multicast, and they have those specific IP addresses. This we believe is for testing and or military.
So after class C, the sub mask is very different, right? It's still 255.
Minimum
right?
of minimum of at least a C.
So C is its limit.
On D, you can't go the other way around, remember, right? You can't go the other way around on you can't go from a class C IP address or class D IP address to C, but from here it's multicast. So if you come in here, you're not gonna you can't set it to 255, 255, 255, 255. The multicast, they know exactly what they purchased, and then they have a set subnet mask that is given to them.
Okay, that makes sense for me. And then E class is just experimental military.
Yeah,
Doesn't really
there's no
matter that much.
default. There's no real default IP addresses for those. Those are not being used by us, so you don't have to worry about those. Just need to know what the range is for those classes, right? And how do I figure it out real quick? Boom, I know that if I turn this on, that means this guy is on 128. Anything below is obviously class A. The next range, when does it start? 192, so -1, that's gotta be this guy, 191. That's when he ends.
Okay, it's starting to make sense for me. And then, of course, there's private, which we're going to talk about later.
Yeah, so public and private, we're gonna be talking about real soon.
I got so many questions, but I know I shouldn't give them out yet.
Actually, you know what? Stays like that. Any questions? You do realize here that because it's a B class, these two here are reserved completely to the network. Then anything I do here will decide for if it has to be divided up. So if I wanted to divide this guy up a little bit further, I can use a C class to break it up into more pieces. I can't use an A class, so that's going to create the problems with public and private, which we're going to learn real soon.
Diego, this may sound like a dumb question, but can you explain exactly why they're separated? I know there's the network and the broadcast. I understand the broadcast has to be reserved, but what about the network itself? Why does that have to be reserved?
The network, how will I know where I am? How will I know what network I am? I know what the broadcast is, but how would I know what is the address for this network? Remember, this is for a computer to understand things. So it needs to understand where do you lie, right? And then it needs to understand in this confined area, who's the broadcast guy, the guy that's going to be broadcasting, and what are the IPs that are available, so that when a router needs to make a decision and he sees this packet that's coming to him, he can basically, or frame, whichever you want to call it at that point, when he sees this and it's tagged with that information, he has to be able to decipher, is this traffic for me to route outside, or does it just stay here?
So a safe way to say is that the reserved network is not an address you use for the host specifically, but it's just meant to say this is the segment. Is that correct statement?
This is the network address, is the address for the network. It labels it. If you want to call it anything, it is the label for the network. Everybody that from the IP, for instance, and this one that's here, everybody that is in this network, right? All the way up to, we said this one's being broken up every 2, right? So then all the way up to 21.255, from 20.0 up to 21.255, the network label or name, lack of a better thing, the name of that network is 10.168.20.0 for everybody that's in there. That's the name of the network, the house that they're in, the LAN, the local area network that they belong to. That clarify it much better?
A little bit.
That is the LAN name, because after that, I have to go out the WAN. This is how I know what LAN I am in. Otherwise, if it doesn't have my LAN address, it has to go out the WAN.
I'm just confused because I can't visualize it correctly.
You ever live in an apartment building?
Yeah.
Pretend this is the address for the apartment building, and these are all the apartments that are contained within that apartment building.
Okay, but then you go to another segment, right?
Now you go to the building that's next door, and you got a whole bunch of apartments in there. Depending how you divvy up the network is how many apartment buildings or hosts that you can have. Now, depending on how you break it, you could have more apartment buildings, which is networks, or more apartments available per tower.
Okay, so I'm starting to understand it more. So the host reserve for the network is basically the building. Then the host is basically all the hosts you can you have, but another minus is the broadcast, where you can think of it as the office.
The main office, yeah. That's a room that you lose, right? Exactly.
Okay. All right, that makes better sense for me now.
That makes sense to anybody? Or did I just completely confuse them now? You only have so many available, right? We agree that there's only 32 bits. So this is how it plays its little game to be able to squeeze itself in and out, depending on how many networks you want or how many hosts you need. That is all determined when you meet the actual customer or when you're designing the network. That's not going to be where a help desk is going to be dealing with this. The only point that they will deal with this is when they're checking the computer. If the computer has an IP address, or if it has a static IP address, the technician needs to be fully aware of what they're doing and how it impacts it. We don't have to be professional in this. All we need to do is to be able to decipher what's an A class, what's his default IP address, sorry, subnet address, and the ranges that fall into these. Any questions about the ranges before we go into the actual aspect of what's public and what is private? All right. As for this sheet, I will be uploading it. We'll continue to fix it as I go along. As I said, this is just so you guys understand how it works exactly and how the IP address is being broken up. The main thing that you need to be able to decipher is the classes and the actual IP classes and the actual classes of subnet masks. Always a tongue twister for me. Any questions? Okay. So we were just covering here the amount of networks. So basically a class A, a regular class A has 126 available networks with a total of 16 million available hosts. While a class B network, because of the slam, you see the wall, the blue wall versus the red host. Now the wall has moved over. I have a total of 6. Oh, sorry. Thank you. We are in slide 17 out of 42, and hopefully now you can see my screen. Can you see me now? You can see it now, guys?
Yes.
It's on the screen now.
Awesome. Thank you for letting me know. All right, so then here's the class A I was just stating. Here it goes to 126 networks. Why do I only have 126 networks? Anybody explain to me why?
The bit value?
Correct, it's 126, but technically I told you it's from 10 to 127. So I should obviously have at least 127.
Wouldn't that be because we have to reserve the IP address? I mean the network address and the broadcast?
Exactly. And at the same time, we're losing one because of the 127.
Oh, you're right. I forgot about that.
127.0 loop back. And here in the B, we have the 16,384 available networks. And this one, we have 534. You have here 2 million networks and 254. And this one's obviously much easier because in the last octet, we have from 0 to 255, right? Which is 256. And we agree we need to subtract 2. So that means I have 254. So next thing we need to figure out and how we do this is based on the actual subnet mask. As I spoke earlier, we look at the wall, and now from the wall, wherever the wall is, the wall we said was here, right? I count the amount of zeros that I have available. So we'll do this example here as they had over there. Put the wall in here.
So stop.
I'm gonna put it in here like it was in that one over there where it was the wall is in here where it's 254, so you can see why and how. So all we do is count the amount of zeros. If I count the amount of zeros, how many do I have?
8.
So if you agree, although there's zeros, I'm just gonna turn it on. I have a total of 256 available numbers because it says 255 plus the 0, it is 256 6 numbers available. Correct? You guys agree?
I agree.
So minus the 2 that we're losing for the network and for the host address, I have 254 available host IPs that I could assign to anyone, including a router, whoever I want. We'll do this now again here this time. We'll shorten it this way. Put it this way, because that way it gets annoying. Now the wall is here. So if the wall's here and I have 7 bits on, hopefully you guys remember the little pattern of what number that should be. I have everything except for 128 on. What is my number? It's 1 below it, right? So what's 1 below 128?
127. 168.
It would just be 127.
127.
That is correct. So now if I subtract 2 from there, how many I have?
It says subtract 2. 125.
That's how many I have available, because I lose 1 for the host address and 1 for the network address. Now let's make the wall go this way. I'm going to put all zeros here. Now, how many hosts can I have?
What's going on?
All right. I have a subnet mask of 255, 255, 255, I'm sorry, 254, 0. The wall has moved over to this side of it. How many hosts can I have? So how many zeros? How many zeros do we see here? How many zeros?
9.
Okay, so what's 2 to the 9th?
18. Or is it 81?
No. Yeah.
Is it 81? Or is it
2 to the 9th, it would be
56. 256.
512. And I'm aware. 2 to the 9th is 512.
Yes, yes.
So now that we got to there, minus 2. Minus 2. 512 minus 2.
510.
That is correct. That's how many available IPs I have for the network. That's how the subnet divides the network side from this side. Now, knowing that the A, B, or C type of network is how you know if you can count what you can count on the left side. Since it is a 10 address, right? I lose this here. It's completely reserved to the network. I can't count it. So now I can only count these ones that are over here. I count these ones, and I count all of these ones. And that tells me is 2 to the 15th. 2 to the 15th minus 2 gives me 32,766 available IPs. At that point, you need a calculator. They will give you a calculator if it was, but once again, this detail, the most you need to understand is this. I'm just telling you how it works and where it divides everything and how you can get your counts and how the counts come about.
I have a question. supposed to be 512, right?
If it was a regular IP address here, it was 512, yeah. Without counting
then
what it is
would-
over here.
And then you would minus it too, correct?
-2, yeah.
I have a question. So if we minus 2 that, does that give you an accurate representative how many hosts you have?
Available hosts is the key word.
Available hosts. Wouldn't it be smaller because every segment has to be one network and then one broadcast?
That's the -2.
But
The
we only did
-2 is
once
the,
though.
what?
But we did the -2 on the actual host, right?
We did the -2 to the number that we have available. The available here of all this that's here was 256. That's the available numbers from 0 to 255. The available quantity is 256. From there, I must subtract 2 because we agree that I automatically lose 1 to the network and 1 to the host address. That's why you must get the number that you have and now subtract 2 so you can determine how many IPs are available for you to use. Available IP that can be assigned either by a DHCP server or manually by the person that's configuring the network.
Okay, I get that part, but the part I don't get is that when you segment the network, wouldn't you have to do that again? So they're all sharing the same network and broadcast, no matter what they've been segmented, right?
Each segment has its own broadcast address. Each network has its own broadcast address. Every single network has its broadcast address. So in other words,
wouldn't it be -2 every segment, right? So why is it 500 and
no. You're getting confused. You're getting confused. Let me show you what happens here now. The reason why I have 510 is because it's gonna, this one here, right? We're looking at, let me double check, make sure. We have this guy here, which is the IP address, and I moved it to 254, which we said was 512. The IP here will start at this factor, which is 20, right? And it's gonna change on every one, right? So that means right here on every 2, sorry, we're over here, right? We said 254, sorry. We're on every 2. So 220, 221. So we agree that this is 256, right? So if between 220, 0 and 220, 255, we agree that's 256, right? Yes or no?
Uh-huh.
So you have 20 here. You have between 220 to 0 to 220, 255 is 256 addresses, right? Now it finishes on 221, 255, which is another 256 addresses. So 256 plus 256 is equal to 512. That's all the IPs that are inside this network. 512 IPs. Now I lose the first one to the network and the last one to the host. So .0, which is the first one here, is the first network address. And now my broadcast address is 21.255. 20.255 is not a broadcast address at that point. It is an available IP address to use. Anyone can use that IP address because my subnet mask, it has divided it in here. It's being divided in here. So it's being changed in here to be making it bigger and bigger. That's what it's doing. You only lose 1 per network. Not
starting to get it. So basically, every segment is what's available to host. So you have to add up all the segments, and then you can know the whole total
I'm
amount
not,
of hosts.
I don't know why
right?
you're calling this what you're calling segments. That's where I'm getting confused.
What I mean by segments, I mean like, I don't know. I'm just very confused because I know that I call it segments because I know when you're trying to find out the range of the host, and then when the network changes, it's like, for example, I know like a WAC 24 is usually every like I think 24, and then you have the next network range, and then the next one.
Well, you just said 24, right? So that would be 8, 16, 24. So all the ones will be filled up. So a CIDR 24 would be up to here. And now I have it all filled up. So if it's all filled up, it basically changes over here only. Now let's do only a CIDR 16. So we're gonna do CIDR 16 now. Let's see, 0, 0, 0, 0, 0, 0, 0, 0. So now I have 2 to the 6. Is that 2 to the 16? Yeah, 2 to the 16th. 2 to the 16th minus 2, 65,534 available IPs to use. Because the network address is 10.168.0.0. That's the network address. Then the broadcast address or the host address of this guy is 10.168.255.255. That's the broadcast address. We'll do it one more time. We're going to make it a true A, which will be a class A address. We're going to make it a CIDR 8. And the CIDR 8, this IP address now, which I haven't changed anything except for the CIDR, and created 255.0.0.0 as the mask, has changed completely the first IP or the network address. It is 10.0.0.0, and now the last IP available or the host address is 10.255.255.255.
I have a question. What's a CIDR? I don't even know what a CIDR is.
CIDR is short term of this little hash or forward slash, which is basically how many bits the network has. That's basically what it is. As for the actual name per se, I'm pretty sure we could look up the name. It's classless interdomain routing. That's what CIDR, the word means. CIDR. CIDR. It just lets you know how many bits are turned on. It's a short way of me writing, instead of writing 255.0.0.0, I could just say 10.0.0.0/8. Otherwise, if I'm writing it down, I need to put 10.0.0.0 and then right below it 255.0.0.0. If I was writing it on a piece of paper or anywhere for a human to understand it.
Where exactly does the -8 come from?
/8, that's because there's 8 bits on. These 8 were turned on, which is equivalent to 255. Now I turn on 16 bits. I turn on 8 bits more. I turn on 8 bits more. It's now CIDR 16.
Okay.
I take away 1, it's CIDR 15, and the subnet mask is written 255.254.0.0. That's the shorthand writing for this guy here. The shorthand writing. That's all it does. I don't have to write all that.
I get that part.
All right, so let's go back to here. We need to make sure we understand what a class A is. His default subnet mask, that means he loses everything here. And then basically it starts from this to 126. We get the B, we get the C, and the D. Any questions on those or the default masks? Besides the mayhem that's going on the other sheet. Questions, doubts? We can use our time in the study group if we want to dig a little deeper into that. All right, so let's go back here now to. So IEEE basically has assigned specific public IP addresses and that are obviously provided to you by your ISP. Most of these times you don't have a static IP, you have a public DHCP address, where if you wow, if your modem is disconnected for long enough, just like any other DHCP, they'll assign another IP to you later. Costs a lot of money usually to have a static internet IP. Just take note of that. They are also classified by the octets that we explained already. For very large networks, the ones that have a lot of hosts in the range 1 through 126 is being used. For medium-sized networks, they use from 128 to 191. For smaller sized networks, they use the 192 to 223. Then the multicast, we stated, was 224 to 239 and 240 to 255 for the testing purposes. Questions? Here's a list of public IP addresses. You don't need to memorize them. They're just letting you know there are public IP addresses. You'll notice here, I believe Google should be available. No, it doesn't say. Is Google on this? It's 8.8.8.8. I know for sure it's theirs. They don't have it here. They just list those there. So here's your actual private addresses, which you should know. You don't need to know the public addresses. Why do I not need to know the public addresses? Can anybody tell me why I don't need to know it if they know my mayhem? Why would I not need to know a public IP address? Because if I know the private, then everything else should be public. So memorize private is much easier. Class A private, 10.0.0. And since it is in that range, it changes on the second octet all the way up to 255. We remember now, here he is, Class A, here is his default subnet mask. Class B, private, is 172.16.0.0. Key right here, look at this. It's in this octet that it changes, and it has the thing. It's in between 16 and 31. Be very careful. There's a lot of people that believe that it's the whole octet, and it's not. Second range, which is the IPPA we mentioned earlier, is the 169.254.0.0 up to 255.255. This one here contains the whole octet. Only that octet. You see it? That's why it gets confusing for some people, because they think that both of them have the same rule, and they don't. Questions? Doubts? Next one, Class C, which is the most famous one. Everybody usually has this at home, is the 192.168.0.0. And then here goes 255, 255. Those are the Class C ranges. Anybody find anything weird though about the class C address? Of the private class C address? Anybody find anything weird about it?
It's including class D and E.
We say that this is the subnet mask, right? Which makes us lead to believe, if we try to get some type of pattern out of this mayhem, that maybe it only changes here when it comes to the range. It is true, it only changes here, but the available IP addresses are the actual whole 2 last octets. So be careful to think that it's only the last octet because of the fact the subnet mask does divide it on the last octet. I totally agree with that. As for available IP private routable addresses, they start from there and they end there. Question. So we said earlier 127.0.0.1, that whole realm is reserved for loopback address. 0.0.0 is unassignable. We all agree, because if at one point, even if I had the 0, it's will be reserved for the network anyways. 255, 255, 255, 255, full blast, that's broadcast. This happens always. Those IP addresses that you see there, there's no way you could use them. And 255, 255, 255, if I don't have an IP address, you best bet that's the guy that I'm screaming at. If I'm a computer that just turned on and I don't have an IP address, I'm sending all, at the MAC level, I'm sending it to FF, 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 all Fs. Why? Because that equals broadcast, straight Fs. Because if I have all bits on, it equals what? If I have 8 bits on, if I have F and F, which is 2 nibbles of Fs, which means it's 8 bits turned on, how much is it?
32.
If I have 8 bits on, if I have a whole octet on, what's the number?
255.
All right, that's the reason why. So you can understand at the MAC address level, when the switch sees it, he's seeing FF colon FF colon. That's what he's seeing when you're broadcasting. But when it's coming to the level of the IP, it's already changed to the 255.255.255.255. That's why you need to also understand hexadecimal versus binary versus human 10-base language. Any questions so far on the classes and the private addresses? So anything else that's not in this realm is a public IP address. So if I told you 191.168.0.1, is that private or is it public? 191.168.0.1. Is that private or public?
Public.
I'm sorry?
Public.
That is correct. Now, is that what type of address is it? Is it a class A, a class B, or a class C? The address.
C, I believe.
I think it's the same.
Class C starts at 192.
Wait, what was the numbers again? I'm sorry.
B.
The numbers we saw in the Excel sheet, class A
No,
is between here and here. Class B goes between here and here. Class C goes up in between here and here. So 191.168.0.1 falls somewhere inside the B class. So his default subnet mask for that public IP address will most likely be there. Default, I said. Keyword default. I can have a different subnet mask as long as it's smaller if the provider decides to put me on a smaller subnet mask. Any questions or doubts? So the example here is that most likely the provider may have the whole range, but he'll give you a smaller subnet mask so that you only use your IP, your little area. So you don't, so it doesn't waste so many IPs, public IPs. Any questions? So just memorize these here, guys. These are the most important IPs you need to know. After you know what is the private IP address, then you know what is the public IP address. Also, remember what is the default subnet mask of every class. You need to know that. And lastly, make sure you know what type of class A address is available. Sorry, what's the range for class IP addresses? Each range. What's the range for A? What's the range for B? And if I know how to do it, it's because I turn on the first bit, is 128. That means the next one starts at 128. I turn on the second bit, that's 192. That's where the next one comes in. I turn on the next one, that's 224. I turn on the next one, that was 240. Next one was 248. What is it? I think it goes only up to 240. Whatever. IPPA, that's the automatic private IP address. TCPIP feature, as I stated before, that Microsoft gives, and it has a /16 or CIDR 16 network. That's how it's actually created, and allows anyone that is in that network that has lost a DHCP server or does not have capabilities to talk to the router, at least so that they can be able to talk to each other, Windows will assign you an IPPA address. Most likely, you're not going to have, obviously, a default gateway to get out, but you will be able to at least to talk to each other. Any questions for the IPPA? All those addresses are lost. Those are a private IP address that is completely lost. Nobody can use it. Unicast. This basically travels from a single source to a single destination device versus broadcast. This travels from a single source to all destinations in the network. As I mentioned before, the broadcast address, sorry, the broadcast address is this. No matter what, if I don't know what network I'm at, I would broadcast to that. At the same time, there is a host address that has its own broadcast address for that network. Any questions so far? So that broadcast address, if I use this one here, would completely just broadcast only to that network, versus when I first turn it on, it will broadcast to every single network that is connected to the switch. Doesn't care what subnet is in there. There could be 15 different subnets connected to that switch, and every single subnet will receive that information. Multicast travels from a single host to a specific multi-destination. That's what the Class D is created for, to be able to multicast to those groups. Don't get it confused with a broadcast.
That example of subnet right there, the 172.16, that is that class B?
That is Class B, correct. That's a Class B. That's both a Class B IP and it's a Class B subnet, because it's only CIDR 16 or /16. Make sense?
A little bit.
Just got to be able to read it, guys. I just want to make sure you guys understand the background of it too, because if you don't understand the background, this is going to get worse. IP version 6 has 128 bits expressed in 32 hexadecimal, divided in 8 fields. Rules to abbreviate the address is that all leading zeros are omitted, just like in regular humans. If I have $100, although we can say there's an infinite amount of zeros going to the left, I am not going to write that down because that would actually be ridiculous. Now, if I had a whole infinite amount of zeros going that way, I surely want to put it in front, behind the one, so I can get billions of dollars compared to just $100, right? So, one thing to denote that when you do that, sorry about that, I had to do it. You could only then abbreviate these zeros in the middle once. If there's any other repeating zeros, for instance, if it would have been 00, BA, 00, it's not going to work to break it here. You saw it here where it put that. So it got rid of all the leading zeros. We all agree? We have the Charlie Frank here. And then we have this set of 0. This has now become just 1 0. It uses a subnet mask. Well, obviously, that's already prefix length is 64. The loopback address is simply like that. That's how simple it is. That's exactly how you write it. Not 127.0.0.1. That's the loopback address. Any questions? Down. Another thing to denote, the zeros are all gone, but the colon is not. You'll notice here, all zeros are gone. I have a colon, then I have another colon before I can start my CF. Questions? And no, I believe you only need to know how to go back and forth to be able to get an IP address. You don't have to know the ins and outs in details. They'll give you that. We'll work on it either on lab if we have time with filling out the sheet, or you'll be able to see the details in the book. Once again, you just need to be able to understand it, that I'm aware of. I'm not going to go into high-level details of asking you any other questions except for how it works, the basics. Okay, so I think those are all the answers. That was a good job there. So number 1. The first one, 169.254.2.10. Can somebody help me out? Is that class A, B, C?
Class B, Aptipa.
Okay. Next. Christina, can you help me out with the next one?
Class B.
It's 11.7.7.4. I know it's hard to read. It's 11.7.7.4. So is that A, B, or C? It starts with what?
B. Hello?
Okay. Okay, B.
I think
Does
it's
everyone
C.
agree? The first number is 11. So if it's
I
less
think it's
than
C.
if it's less than 128, we said it would be A, right? So anything between 0 to up to 127 is the class A. So then
Oh, yeah,
class.
yeah. I'm sorry. Yeah. A.
Okay. So now that we know it's A, is that public or private? It starts with 11.
It's public.
Everyone agree? Is that a public IP address?
Sure.
Huh? Why would I know that that's a public IP address? What helps me determine that that's a public IP address?
It's a
I
class
just
A.
said zeros.
Okay. Give me a sec. All right, I'm gonna leave this up and so that we can have it at least here. So we said it was a 11, right? So 11 we said was anywhere between 0 and the next range starts at 128. So that means anywhere between 0 to 127. That's the range of an IP of class A. The private IP address in class A, the only guy that is a private IP address is 10.0.0.0 and up to 255. If there's any other class A that is being given to you, an IP address that falls as class A and it does not start with 10 dot something, by default, it is public. So you only need to learn these 4 here. Obviously, also obviously the loop pack. So if you can learn these 4 here, the rest automatically have to be public. That's what they are. So what's the next number that we have available, Teresa, on that other slide that you guys have open, so we can keep this slide open?
The third one where it's 221, 221, 221, 221.
I guess so. So 221, 221, 221. Jordan, is that a class A, a class B, or class C?
Class C.
Everybody agree, class C?
I agree.
Now, Jordan, is that public or private? Loopback, a pipa, what is it? 221, 221, 221, 221. That public, private?
I believe it's public.
That is correct. Next one, Carlos.
All right, let me check the number. It's 172. Do I have to read the whole number?
Yeah, you need the whole number. Yeah.
Okay. On 172.30.41. Well, 4.1.
Okay. Is that B, A, B, or C? Sorry.
That would be class B.
Okay. Is that public or private or IP?
Public.
Everyone agree?
I disagree.
Name's private.
Well, let's see here on the class B, private. He said it was 172.30 was the number he yelled out?
Yeah.
So that would be in the range of 16 through 31. So yes, I would have to agree with them. It is a private internal network because it's inside that range.
Can you explain why it's private
Yeah,
again?
please.
Okay. The standards for routers and everything, they are programmed this way to recognize these numbers. So this range of 172.16.0.0 is where it starts. So then when I get to 172.16, let's say .255.255, the next one is .17. .0.0, that's still private. 18.0.0, that's still private. 19.0.0, that's still private. All the way up to I get to 31.255.255, that whole range of numbers is reserved to the private networks. So it starts at 172.16.0.0. When he goes through his vicious cycle and it gets up to 255.255, the next range automatically, when he finishes here, he goes to 17.0.0, but that's still the same private network. It's obviously, don't get confused with the way it gets divided. We're talking about the actual range that's reserved. Forget about how it gets broken up. Not how it gets broken up. I can care less about that. What I'm concentrating is what zone, from where to where is it reserved for private purposes. So anything that's 172.16 all the way up to 172.31. So it's 172.30 falls into that range.
Okay.
That makes sense?
It does, but I also don't understand. Like,
More or less.
I don't know.
Okay.
I don't know what question I have to ask.
So let me show you how you guys understand how to count in base 10. Let me show you how this works out here. All numbers start from the right to left here, just like in a regular human language. The thing is that here, when I get to 1 all the way up to 255, when I finish, just like you could pretend I'm gonna write the number 10. If it was 0 through 9, now I gotta turn this into a 0 and I gotta go over here and put this into becoming a 1. You agree? Pretend this was 0 through 9. Now I wanted to represent 10. I have to turn this little digit into a 0 and then put a 1 in front of it. Do you agree with me?
Yes.
All right. So now that we agree with this, we can pretend that this is the ones column, for lack of a better name. This is the tens, this is the hundreds, and this is the millions. All right? But the range here of each area is 0 to 255. So as soon as I get to 255, instead of 0 through 9, right, it's 0 through 255. When I go and I'm going to carry the 1, I carry the 1 to the next guy, and I turn this into 0. So it's 1.0. And then I do the same thing. I go all the way up to 255. I turn this back into a 0, and I carry the 1, 2.0, all the way up to 255. One more time, I turn it to 0, 3. It just keeps on going. It fills up the bucket, and as soon as he gets to 255, turns it back to 0, he goes to the next octet, 3, goes to 4. That's how he counts.
I think my confusion is the fact that there's 2 class Bs. Is the other class
for private.
B?
That's for private addressing. This is to know what are the zones for private addresses. Now, the reason why class B has 2, you need to notice that this zone, really, you're never going to really use. This is the IPPA address that Microsoft has reserved so that if you have problems with your DHCP server, this is the address range that it's going to give you on your LAN. You will never use this, assigning this to any computer. You're only if you have problems, that's why it uses this. That's a zone that the IPPA zone, see? 169.254.00/16.
Okay, I sort of am following now.
So that whole range is reserved for Microsoft's invention for a solution. If you can't get an IP address, so at least you can communicate an IP to each other. Every computer that has lost a DHCP server can at least get this range of IP addresses so that they can talk on the LAN.
So typically the address range that isn't IPPA, that's class B, typically would be private.
It is private. Yeah, it's an IP because it's the LAN that's down. And so now Microsoft is giving you a private LAN address. That's the range that is reserved. So the true ones, the ones that you will use and you will assign is 10.0.0.0 to the 255s here. The other one that you actually use is this one here, which is 16 through 31. And the other one that you actually use is the 192.168. Those are the 3 that you really use as IT professionals, reserving either on a DHCP server or manually assigning it yourself. This one you just get, as long as you remember which one's IPPA. IPPA is on a B class, and that's a private address. Just need to recognize it. The last one that you lose that is not a public address is these 3 down here, which is the loopback, the 127.0.0.1, and the 0.0.0, and obviously the broadcast. Any other IPs there on that slide?
192.169.5.240.
Okay, so is that A, B, C, or D? Or A, B, C? You know me.
C.
Everyone agree that's C? Now, is that public or private?
Public?
Public, right? Because it's not in the range of not in the range of 192.168, right?
Yeah.
All right. As long as it doesn't start at 192.168, it's got to be public. In the range of C, we're talking about, right?
Right.
All right. Any questions on how to decipher between A, B, or C, or deciphering if it's public or private? All right. IP version 6 has unicast address. These 3 unicast address are the global unicast. with a prefix of 2000, the link unicast, which has the FE80/64, and the unicast local address of this one right here with the FC00 or FD00. Multicast address, as we know, gets delivered to all nodes in the network, and any cast address used by routers identifies multiple destinations, and packets are delivered to the closest destination.
You have a question on IPv6. They don't use broadcasting, right?
I don't think there is a broadcast there's only multicast and unicast and anycast. I'm not aware of the broadcast, but we could look that up. If it doesn't have it here, we could look it up. I don't think there is. I've never, once again, I'm not very savvy on IP version 6. I haven't really dived into it very well. But we can look at it without any problems. Give me 1 second, please. All right. So, needle pulling thread. How do we obtain IP addresses? Somebody can help me with this slide. I'm running out of gas here.
How to obtain an IP
Okay, Jordan,
address
thank you.
dynamically by DHCP, Dynamic Host Configuration Protocol. A DHCP server assigns IP addresses automatically from a pool of addresses. If DHCP fails, a people will be assigned automatically. Or static addressing. IP addresses are entered in manually. Errors here are usually human, and the main use is for devices that should never change, i.e. printers, servers, or gateways. Use the command prompt to view if your computer has DHCP enabled to receive an IP address automatically. Click start, type CMD, then enter ipconfig/all.
So this basically gives me my internal IP address, my subnet mask. It lets me know who my DHCP server is, my DNS servers, and all details, even my MAC address information is in here. If I needed to mess with my thing, I'm not going to do that, but I'll put a question mark. I can show you all the available. I can renew my IP address. I can release it, depending on what type of problem. So if I'm stuck in an IP address and they tell me that they fixed the actual DHCP server, I can release that address and then hit renew, and now it will go and request again. As for broadcasting, I did get a chance real quick to look that up in version 6. There is somewhat a version of broadcasting, but it is being submitted through the multicast address, like I said earlier. So it is through the multicast address. Any questions? So as we stated, the DHCP server is the one that gives you the IP address. It usually resides within your actual network. If not, the router will have the actual information to route it to the actual DHCP server if you don't have one within the facility. And then obviously static IP is the ones that you can do yourself manually. Noted here, as we see DHCP, you see that automatically obtain everything and you don't have to write anything. As for being able to be specifying a specific IP address, you are, by just toggling here, you can put your IP address, your subnet mask, your default gateway, DNS servers. By pressing on advanced over here, you could also add the Win servers and or other NetBIOS or NetBIOS server information, I believe. Any questions, doubts? So the static IP, basically when I go into my control panel under the network and internet or network connections, I have my local area network. I can actually right click to it and go in here and go into the details of it. I click on here where it says IP version 4, and now I can specify what address I want. And then I click advance if I want to put in the wins and or any other information in the back. If I want extra DNS servers or any Win servers information. The gateway, that's specifically like we said before. You guys heard that word gateway. Well, here he is. As I told you before, the router basically usually is the one that's going to be your gateway out into the internet. From the internal network to the external network, be wherever it is. Even if it's going into an intranet, it's going out through the router. It translates all private IP into a public IP addressing. And in order to communicate, it has a NAT, a network address translation tables, which keeps track of all of your IPs with the port that you wanted to talk. You guys remember my TCP IP stack. So when the router gets it, he has the port that you wanted to talk, right? Because you're coming, the application's coming down, right? So now I have that information, that packet information of the port, all that information's in there. I keep track of what your IP is, the port you were on, and the IP and the port that you want to go to. Now, okay, I have that. But when I send it out, I can't send it on the exact same port 80, for instance. I need to reserve now a port for you. So I get an arbitrary port, one that's not reserved for anyone. There is many ports out there, but there is the ones that are not reserved for anyone, and I give it to you. So now I put that information, everything that contains your information of that NAT and that port number in there. So that when that mail comes in for you and it says here, router, here's what you asked for, and it says what port it's going back to, now I go in and say, oh, the port, oh, that's this internal IP address. Here you go. And I remove my information of the packet and I put back your information so that you can be able to listen to it on the LAN and pick up the packet. Lost yet in translation? Questions? So the router also, if I'm talking, as I stated earlier, if I am talking on this network and the router notices that whatever you're talking or whoever you're trying to call out, the IP that you're calling out is not part of that network, he will automatically grab that packet without anybody asking him and start routing it out. Because remember, the switch is going to start asking for names. So if the switch and DHCP server, nobody's answering, your best bet he's listening, because it's going to get broadcast, right? So as soon as it gets broadcast, he's listening, he looks and he says, hold on a second, that's mine, give it to me. Okay, here you go. Next, fully qualified domain name. This is how Google.com is translated to you. There is a computer who's able to identify what www.google.com is and it represents it in a number. Obviously, eventually we all agree it's all ones and zeros, but it needs to be able to translate from the friendly name, the FQDN, which is the fully qualified domain name, into a number. Otherwise, it will not be able to. Who does this? A lot of times the DNS server. Your domain name server resolves the actual host names into IP address and vice versa from IP to name. So if I come into my computer here again, and I go into my little friend here, and I tell NS lookup to look up www.google.com. And now he's gonna say, this is the guy we saw earlier in my actual address. That's the DNS server, if you guys remember. It said it in my IP config. Here's the address in form of IP version 6, and here's the actual IP. That's the equivalent to google.google.com. If I go here, nah, it's obviously not gonna. I can ping it, but I'm not gonna be able to. They don't have. I have. Oh, that's right. It's the port. I have to do a port most likely. That's 80. Who you got? Anyways, questions, doubts? Did I close the wrong one? Okay. So he's the guy that's going to be able to decipher what's the name equal to. There's plenty of them out in the internet. Your computer doesn't know all of them. So whenever you register your name, you have to register your domain name somewhere. And those servers throughout the internet are all talking to each other. Even internally in your company, you have your own reserved DNS server, which are not public IP addresses. They are private IP addresses that are inside the intranet of the company. Those DNS servers also are responsible usually to get the DNS translations from the internet, and they update their tables to provide it to you. TCP, as we said, is a transmission control protocol. It is connection-oriented protocol. It actually checks and confirms that it is connecting. It checks whether all data has received and sent on both ends. It obviously being used by like web browsers, emails, and other applications. FTP uses UDP, which you here have is a connectionless protocol, best effort, used for broadcasting and streaming, usually video. Virtual Local Area Networks, VLANs. We had a lot of issues because there is companies who like to segment their networks. As we saw, the 192.168 network, I can divvy it up a lot, and it could all be inside one company because maybe I don't want people to be able to see accounting's information. So what was happening is that if people are buying these expensive switches and were running out of ports because they were using different switches just to be able to segregate and ensure that nobody is able to talk to each other. Because anybody that's savvy and can figure out what IP range is the range of accounting, I can go in and maybe mess around or bring my own computer and put an IP range that's there. But what happens is Cisco and several other switches have created VLANs. They're very, very sophisticated device who's able to virtually segregate LANs inside the actual appliance, mimicking like if you actually have 4 switches instead of 1. Completely, only those ports can talk to each other. To even top it off, that you could actually program each VLAN so that when you're on that LAN, on the switch, you could have an IP that you're reaching in that VLAN. You waste less money because if you have switches, as you can see here, VLAN 1 here is dedicated for port 1, 4, 5, and 12. While VLAN 2, I have port 2, 8, and 10. And then VLAN 3, which is completely different, separate department, is dedicated these ports here. What's awesome is that then I could actually traverse trunks and go from one building to another or one side of the facility or the other and mimic the exact same thing so that if something happens and I still need users to be in these separate VLANs while they're out there with ease, without having to buy separate switches, I can be able to segregate it. One appliance, I think it's 0 through 99, you have available VLANs. Any question what a VLAN is for? So is it just a virtual LAN to separate further a switch into pieces? Virtually. Virtual private networks. This basically is where the Wild Wild West comes along. Some companies can't afford these T1s or OC3 or fiber links. So they'll go and get cable. What happens though is that if you need a connection from here to the people that are in their house or to a separate office in New York and everybody's connected to the internet direct, now you can't get back to the main office. Virtual private networks allow a secure private network that is basically creating an encrypted tunnel over the internet. No one can see the actual traffic that's inside. It's garbled or completely secure. Usually there's a VPN server or a router at one end to be able to then allow the laptop or the separate, if it is two routers, because if it's two big buildings, sometimes they have two VPN concentrators on both ends to be able to connect the two computers. I'm sorry, the two sites. Questions on what a VPN is?
I've got a quick question for the SOI model. The protocol is an application or a presentation?
SOI model. I'm not sure what you're speaking about.
Sorry, I think I said it wrong. The 7 layers.
Okay, 7 layers. What about the 7 layers? The OSI model.
OSI. What layer does the ISP PP2 and L2 TP would be in? Would that be a presentation or application?
The PPTP is in layer 2 and L2TP, it says it actually in the name, layer 2 tunneling protocol.
Okay, that means EPSpeak is also in layer 2, or is that layer 7?
Which one, I'm sorry? IPsec?
EPSpeak? Oh, yeah, IPsec.
IPsec, the OSI layer of IPsec. I think it's on the IP layer. I could be wrong.
3.
Yeah, it's an IP layer then. On the third layer, yeah. It's in the name, IP. IP security, so it'll be layer 3. Point-to-point tunneling protocol. And this is layer 2 tunneling protocol. And this is now on the IP. So now this gets IP security at the IP level. Any other question on IPsec, PPTP, or L2TP? Network sockets. A software component used to connect the LAN or WAN, but can also be used to connect within the computer. The programming called application programming or APIs. One endpoint between programs connected through a network. Not to be confused with an actual physical socket itself. Example, if I'm reaching this email server, as you guys saw me earlier when I was trying to reach Google, I put port 80. That is a socket. That's the port. That actually explains to him what application I am trying to reach. This little number here is for email. That's SMTP. With this IP, I know that I want to reach here. I am sending emails to this guy. If I'm receiving on POP3, that's 110. It'll be my IP address :110. Or it's not actually the email service, sorry, 110. Mine will be sporadic. Always the guy that's initiating the actual call and asking for the service uses a sporadic non-use port. Forgot the word. I'll get the word real soon. Most likely they have it in here. So the ones that are reserved, usually that's for the servers. That's where you're going to connect to. So you know exactly what application you're trying to get to in that server, because every server may have multiple applications that it's hosting. For instance, a web server can be hosting HTTP websites, and it can be also hosting HTTPS. So then instead of going to 80 The computer will be going to not 443, for instance, to get to the same server, but a different part of the application. That's what the port is. You can say that that right there is equivalent to being your address and this being any room inside your house. Exactly saying which room you're going into. This here is your apartment number, right? As we said, the network address is the physical apartment building. This here, the front is your apartment number, right? And this here will be equivalent to any room inside your house. So if you need to go to the bathroom, you will go to room 25. You want to go see a movie, you go to room 80. As an example. Very bad example, but I'm trying to my best to put it as in layman's terms as possible. Still the same apartment, right? But I'm just going to different rooms inside that apartment. That's the only way it's able to decipher where inside this server you need to get to. And if the port is closed, guess what? He says, bye-bye. Although the IP is up, he's not going to let you in because the port's closed. So it's just as like if you get to the bathroom and somebody locked the bathroom, it's like, nah, somebody's in here, sorry. Same thing. Close. Let you know when we open it back for business. Not coming in. So protocols that are well-known and port numbers for TCP, there's various of them. We have a list that you guys were given, I believe, inside your Google Classroom, if not inside the Quizlets that they're giving you. Communication across TCP IP networks takes place obviously in various ones. Some are reserved with TCP or UDP, and some of them are reserved with TCP and UDP with the number. The next one right here is FTP. FTP is 20 or 21, depending on your flavor of connection. 22 is the SSH, secure socket shell. It's encrypted. TCP. FTP, is that TCP or UDP? Anyone know?
Which one? I can't hear you very well.
Frank Tango Papa. Is that FTP or UDP?
Something's telling me that it's TCP
Correct.
because it has like a password capability.
Yeah. And then there's the Telnet, SMTP, DNS, HTTP, POP, IMAP, HTTPS, AFP, and RDP. Now, AFP is not being used much, pretty much. I believe it's Apple Filing Protocol, if I recall the acronym for it. That was mainly for the Apple Talk Filing Protocol. I don't think it's really, I'm not sure if it's being used still. I don't think so. If anything, it's used in the AFS for the Apple filing services, but it's not being used as for in the Windows world or regular normal. Any questions? So our FTP is the transfer files between two computers. You usually see this also on servers where you could actually FTP to a server to be able to transfer or download information. SSH is a secure socket shell, is used to securely log on information at a remote control computer over a network. That's encrypted, completely encrypted, while FTP is in the clear. Dangerous. Telnet, port 23, is basically used to control a computer unsecured, completely unsecure and dangerous, not used anymore unless if you're like on a very, what's the word again? A sandbox LAN and you're just logging into the switch or something like that. You shouldn't be using Telnet. It's completely in the clear. Everybody understand what I mean by in the clear?
No encryption. So anybody can see in plain text.
Correct. Basically, if somebody's sniffing the network, nobody take it the wrong way, you people in Miami. If somebody's listening into the network and is looking at the packets that are going through the network, they will be able to see what they call clear text of everything that's going through. So they'll be able to put Humpty Dumpty back again and see your password, the ID to your websites, all of that is going to be in there if it's in the clear. If it's secure, it's completely in a secure channel and it cannot be decrypted. And easily, obviously, there is ways of decrypting things and there is hackers out there. But layman's terms, that's the reason why it's like that. Any questions on in the clear or encrypted? 53 is for the domain name system. HTTP is reserved for the web servers. That's also in the clear. POP3 is used for the post office protocol to deliver incoming mail without synchronization. You have to pull the pull service. IMAP is also to deliver incoming emails with synchronizations across multiple devices. You can think about that as the one on your phone itself. It usually has an IMAP connection. And what happens is actually that most was being downloaded at times is just the text and maybe sometimes the pictures. When you click on the email, the pictures sometimes you see actually res up. And on top of that, it usually doesn't even download the file. It gives you an icon that there's a file there. Then you double click on your iPad and it goes, and it starts downloading it for real. Any questions? POP, when I do download, it comes down and it stays here and we'll delete it off the server on the top. That's why it means no synchronization. It comes down, it's here, it's gone. HTTPS is 43. That's the secure encrypted way of going on the internet, 443. RDP is 3389. That's the remote desktop protocol to be able to connect from one computer to the other within the Windows environment. AFP, as I mentioned before, is a proprietary resource from Apple themselves, port 548. DHCP is basically the network protocol for the dynamic host configuration protocol. That is the protocol's name of how and where you request an IP when you don't have one. That's the port. DNS is, as we stated, that's the one where all the messaging that involves processing and responding towards either IP to fully qualified domain names or FQDNs to IPs. LDAP is the lightweight directory access protocol. Usually you see the LDAPs being configured inside Outlook itself is to be able to obtain and maintain directories within companies. They'll have your phone number, your email, everything that's within publicized inside a Microsoft domain, that's inside the LDAP directory. SNMP is a network management protocol. It's an internet standard protocol to manage devices on an IP. So it's a network management protocol. SMB is a server message or management, service. I got it right first time. Server message block. That is a Microsoft protocol used to reading and writing files and request services to the actual servers. That one was very dangerous. I believe, if I can recall correctly, the blaster worm was the one that hurt a lot because of the assumption that since you are in my domain, you are trusted to write to me with SMB messages. Created a nasty worm with that. SSH, secure socket shell. I'm sorry, secure shell. Yeah, SSH. I don't know why they say, I'm used to saying secure socket shell, because that's what it is. Used to pass login information to a remote computer. Obviously, it's secure. It's not like FTP. And it's to control the remote computer over the network versus telnet. It's a secure shell. Just like telnet was in the clear, this one's going to be encrypted now. But it's his replacement, the encryption one. SFTP, This is a secure way of no longer obviously in the clear. It actually is encrypted files when they're being transferred. Secure file transfer. So, any brave souls want to take a stab?
I actually know them pretty well though, so.
Okay, give me the first
Right.
one. What's that
All right,
say?
22, 23.
No, I said the first one. You're giving me off. I said the first one. RDP then, Jordan.
Sorry, which one are we on?
RDP.
Man, remote desktop protocol.
Correct. What's the number?
3389.
Good.
That's what I see.
SMTP. Christina.
25.
Good. Carlos. DNS. Okey-dokey. Lost Carlos there for a minute. Pablo. DNS.
Domain name system.
Correct. What's the port?
That's
53, you said?
yeah.
Oh, sorry. Yeah. All right. Next one. Justin. FTP.
File transfer protocol, and I believe it's port 20 and 21.
Correct. Mohammed.
Sorry, I'm back.
All right. All right. Carlos, then give me HTTP. What's HTTP? What port is it?
80.
Cool. Mohammed, what port is POP3?
Is 110.
Correct. Christina, not Christina, Alexa. Sorry about that, Christina. Or Alexa called you, Christina. So where was
548.
AFP?
Yeah.
548? You said?
Mm-hmm.
Oh, I'm sorry.
Yes.
I heard 528. Sorry about that. Not a problem. IMAP. DeAndre.
Hold on. It's 143.
Yep. And HTTPS, Teresa.
HTTPS 443.
443, yeah. All right. So, we're going to go over here. This guy this way. Number one. Who's the brave soul to take on number one? Daniel.
Do instead.
Which of the following IP addresses is a Class B address? I think it's C.
Everyone agree it's C?
Oh, it's D.
I agree with Daniel.
I think it's C.
I think it's D.
Okay, I got some votes there. B, was that Bravo and Charlie?
Charlie.
Okay. Now let's think about this. So Bravo would be, we said alpha was from 0 up to, if I turn on the first bit, which the first bit is 128. So anything below 128 from 0 to 128 would be class A. So it's not class A. Now, if I turn on the second bit, that makes me go to 192. That's C already. So anywhere between 128 and 191 would be B. And this one falls into, from the looks of it, since it's 168, is B. 224 is not there, 209 is not there, and 102 is not there. 102 is A. 209 is C. 224 is D, I think, right? Yeah, it's D. So there, now that we know that C, is C public or private?
Wait, how do I get number 3?
Public.
Everyone agree that's public?
It's
It's
C,
a-
right?
Yeah, class B address, which is, the answer is C, and the number is 168.212.226.204. I'm being told that that's a public B class address.
I agree.
Everyone see that? Okay. Next one, number 2. Pablo.
All right. We have, which of the following statements names a drawback of using an AP IPA address?
What's the main drawback of using a PIP address?
Well,
Is it well, can I answer?
Yeah, anyone.
I think it's B.
Sorry, I disagree.
Okay. What would you believe it is?
I know IPA is related to addresses that cannot get a DHCP, meaning they can't get a private, sorry, they can get a IP address from the router. Therefore, it uses its own internal, and the operating system gives it that. But that means it can't connect to anything else unless it's within its network range of the IP it chose.
So the IP address, so what's his drawback then?
He's not able to connect to the internet. That's one of the
Yeah,
drawbacks.
that's the major drawback. Although I can talk to everybody that's in the network, it's resolved my problem of me just not getting an IP. Like back in the old days, all you do is just get nothing, and now you can't communicate to nothing. Versus with the new Windows feature that if something happens to your DHCP server, it will give you an IP address with its default subnet mask, and there's no such thing as a gateway. There's no gateway address that it's going to give you. So therefore, you will not have connection to the internet. Any questions or doubts on why this is D? Clients using a PIP addresses are unable to connect to the internet. Next one, number 3, Justin.
Identify the network portion and the host portion of an IP address. I believe that is D, the subnet mask.
Okay, everyone agree? Subnet mask?
I agree.
Yeah. Okay. Next one, number 4, DeAndre.
All right. Which group includes only ports used for email? I'm gonna go with B.
Everyone agree, B?
I disagree.
Okay. Jordan, you were saying what? What do you believe? Mohammed, I'm sorry?
C.
D?
C.
D, I agree.
See, everybody agree with C? Now, although B does have some protocols that are for email, the three email ones that we covered for today is SMTP, which is the simple mail transport protocol. The POP one is for mail to receive, and the IMAP is to receive. One to send there was 25. Any questions? So HTTP, which is port 80, and HTTPS port 443, although you may use sometimes these websites to log on, the actual protocols for mail themselves are those back there. Not to be confused with the little applets that those little web ones give you. Completely different. We're talking about applications at this point. Number 5. Let's see, Teresa.
Can you hear me?
Yep.
Number 5. Which protocol makes the connection, checks whether the data is received, and receives it if it is not? That would be the, that would be the, what is it? Is it the,
So which one is connection based? In other words, that makes sure that everything's guaranteed to get there. And if it doesn't get there, he's going to ask again to be retransmitted.
which one is it? Which one is it? I believe that one is the TCP.
That is correct. That is the connection base, while the connection list was the UDP. He doesn't guarantee anything. DHCP is the one that gives us the actual IP addresses, and then SNMP is the server name management protocol. That's nothing to do with what they were asking. Any questions or doubts? So, are we feeling a little bit more comfortable in reference to understanding your A, B, C, and D IP addresses?
I kind of get it. I'm just confused with the higher understanding of subnet.
Yeah, I get getting the values from the binary and the hexadecimals, but when it comes to applying it in the sense of what does it mean for your host, what does it mean for your network ID, etc., that's where I kind of get lost. I get the math, but not the what does it mean.
I'm in the same boat with Jordan.
Yeah, man, we can play around with that on Thursday without a problem.
I would love that. I need to know this.
Yeah.
Now remember, for the test itself, I believe for certification of the A+ itself, they're not going to be asking you that hard of a question. You just need to be able to decipher what's A, B, C, what's the default subnet masks, and what's private and what's public.
I think my problem is I'm trying too hard to figure it out.
As for ANDing, the ANDing portion, I believe they do not ask any questions on that. They do not ask any questions on actually creating and asking you how many subnets and how many hosts. I'm just showing you more than what, so you guys know how to use it, so that if you do get a job, you don't look like you're lost. Because I don't think it's fair that they remove that portion out of the A+ just to put it in Network Plus and Security Plus. I've seen many students go into Security Plus and Network Plus, and the teacher's like, and you guys don't know this? Because that's how hard it is when you go in there. If you get into Security Plus and you don't know at least the ANDing portion, you're not going to do very good in security.
I agree. I'm in that boat. When I took security, networking, and Linux, I basically had no foundation, and I struggled the whole course.
So just get this basics, which is the IP classes, the default subnet masks, and then make sure that you know that the private ones. So we had the private was 10.0.0.0 up to 10. Actually, that would be better this way. 10.0.0.0 up to 10.255.255.255. What's the next private? Private. This was an A, right? So what's my private for B? Those two of them.
Was it like one?
10.00 or something.
No, what's
10.0.0.
what's the B class private addresses? There's two B classes. We had
I know
the right?
that one.
Oh.
And then the other one starts at, I think, 172, or that's the ending.
You're looking for the names.
I think it start. I'm pretty sure it's 172 something.
Now I'll show you my trick and how I got this one memorized. It's 31, right? 255. So how do I remember is this guy? Is because I know who my loopback is. And I noticed that if it has 127 as my loopback, it's still the same three numbers, but it's 172. That's me. It's the only way I can memorize all this crap. My loopback is 127, which is a private address. So in my B section, the private is 172.16 up to almost 32. Almost 32, but it's not. .16, almost 32. Then if I recall correctly, the next one here, the IPPA one, private address is 169.255, I'm sorry, 254.255.255. What was the last one over here on the C class? That's private.
192.
192 what?
I always forget that. 192, 168.4.
Don't die. 192, 168.
Any questions? I'm gonna upload this Excel sheet back into the same location of the actual classwork. You guys will be able to use it from there, right? You guys feel comfortable now, at least with this portion? Forget about the ending thing for right now. That's just a nice thing to know and how it works and everything and all the ins and outs. The reason I need you guys to understand it is because it will help you obviously decipher how everything works, especially when you're coming up in the higher levels. If you're actually serious about going, this here must be understood first before you start playing with ending. Let's get in, make sure we get the classes down packed, understand who's private. I know who's private, everybody's public, and then I can play around with ending if I have time. Subnet always goes basically from left to right, getting it filled up. So the only available subnets will be 0, 128, 192, 224, 240, 248, 252, 254, and 255. Those are the only available types of subnets that can be. There is no other number available. All right, guys, that's pretty much all I have here. As you guys see, there's also labs still pending and stuff. I'm going to be extending the time to allow you guys to be able to finish and do your labs with enough time. If there's no questions, that's pretty much all I have for you guys for today. And we could do a reflection if you like. Or actually, we haven't even taken the break. If you guys want to leave, you guys can leave now. I have no problem with it. If you have any questions or doubts, let me know. I will stay on for those that would like to obviously have any questions and need help on anything real quick.
I